Okay, we're going to go ahead and get started with our next lightning round talk. And so if we could get the names up, great, fantastic, thank you. If those of you who are on this list, go ahead and please come on up and stand on the right. Again, these are 60-second presentations that give the students an opportunity to tell you who they are, where they're studying, what they're doing, and to advertise a poster if they are giving one. No questions, no slides, and if you do have questions for them, please hunt them down at their posters or at any of the breaks. So with that, we'll go ahead and get started with Keenan.
Good morning. I'm Keenan Stone. I guess I'm a 0-year graduate student. I just graduated from Howard University, and I'm headed to the University of Colorado at Boulder in the fall. And at Poster 90, I'm presenting a project I'm working on at the Goddard Space Flight Center, revitalizing data from the Apollo Lunar Surface Experiments package. Despite being almost 50 years old, this data is very useful for characterizing and understanding the environment in which future exploration missions are going to take place. And furthermore, a lot of these data sets are complementary to and synergetic with more recent lunar missions. So specifically what I look at is constraining lunar surface charging and developing a sheaf profile for when the moon is within the Earth's magnetosphere. So if any of that sounds interesting to you, or you find yourself bored wandering around at 4:45 this afternoon, once again, I'll be at Poster 90. Thank you.
Hello, my name is Alex Judas. I'm a PhD candidate at University of Michigan. One of the major problems we're going to have to solve moving forward on long-term manned space missions and travel is space weather. In particular, solar energetic particles can be dangerous to astronauts outside of our protective atmosphere. That same atmosphere precludes us from looking at telltale signatures of SCPs below 15 megahertz. So a space-based array would be of enormous benefit for tracking these SCPs and predicting where they'll end up, so astronauts can take evasive maneuvers if needed. My poster, number 85, analyzes different possible lunar arrays and analyzes their performance in tracking these SCPs. I offer clear recommendations for the location and geometry of these arrays, and they would also be of big scientific benefit because it would clarify the basic physics of processes such as particle acceleration in coronal mass ejections. In my future research, this array will be just one instrument of many in a synthesized alert system, which will integrate different measurements for optimizing space weather strategies. Again, my name is Alex Judas, poster 85. Thank you for listening.
Hi, everyone. My name is David Burt. I'm working here at Ames with the Basalt and Finesse groups. Just like Keenan, I'm also a pre-doc. I just wrapped up my undergraduate at Whitman College, and I'll be heading off to Stony Brook in the fall to start some studies there. Project I'm working on right now and that I'll be presenting a poster on is working with instrumentation for future human-led missions. Our goal with that is to set up our astronauts with instrumentation and with methodologies that will allow them to maximize sample returns and the overall efficiency of those missions. Specifically, I'm working with a handheld XRF, or X-ray fluorescence spectroscopy instrument. And if you want to come check out that poster, it's number 53. I'll be there at 4:45. Come check it out. It's some pretty cool science. Thank you very much.
Hi, everybody. I'm Zack Morris. I'm a PhD candidate at the Center for Planetary Science and Exploration at the University of Western Ontario. I'm a fourth-year PhD candidate, and my research is focused on mapping ejectafaces around Oriental Basin, which is a large impact structure on the left side of the moon. Can't quite see it from Earth, but you can see it on the big map, which is on my poster, number 35 in room 120. It's about 3.5 light years away at the other end of the conference, but it's worth the journey, at least to see all of the student posters but especially the one with the big map right on the left when you walk in. We'll be there this afternoon, and if you feel like talking about mapping the lunar surface or Canadian exploration in planetary science, come say hi. Thank you.
Hi everyone, I'm Casey Honeyball. I am a third-year graduate student at the University of Hawaii at Manoa, and this year I am presenting poster number 14 on 6-micron water observations of the lunar surface. Ever since the water was discovered on the moon, there's been a long-standing debate on the variations of the depth of the 3-micron water band. Some believe that it is due to diurnal variations. Others believe it is due to competing effects of thermal emission and reflectance. So what we propose is to make 6-micron water band observations of the lunar surface to begin answering key questions to this debate. So again, I am Casey Honeyball, poster number 14. Thank you.
Hello everyone, my name is Markus Paquette, and I guess you could probably say I'm a very dusty person. That's not really a statement about my hygiene necessarily, but more about my research interests. I'm a PhD candidate at the University of Colorado at Boulder, working with Professor Mihai Hurani on a variety of dusty phenomena in our solar system. I'll be presenting poster number 10, entitled The Effects of Asymmetric Surface Topography on Dust Dynamics on Airless Bodies. We're modeling both the plasma environment and the ensuing dust dynamics on the lunar day-side surface over 2 different topographies. We also look at the effects of reductions in gravity to hopefully bring some insight into dust dynamics on smaller bodies such as Comet 67P CG. Some other topics I'm interested in working on include the student dust counter aboard the New Horizons spacecraft, which has been measuring the interplanetary dust population from Earth to Pluto and now into the Kuiper Belt. I've also conducted some experiments where I've cooled mixtures of Regulus simulant and water ice mixtures down to about 100 degrees Kelvin under vacuum. So if you want to talk about dust, come see me at poster number 10 or just look for the big beard.
Hi, good morning. My name is Wesley Chambers, and I'm a graduate student at the University of Central Florida. I'm doing computational experimental work to try and answer the question, what happens when a spacecraft lands or has to interact with the surface of an extraterrestrial body? So particularly, what happens when the rocket exhaust is interacting with that surface? There are a couple of motivations for this. One, the primary reason is hazard mitigation, but also as we see with things like OSIRIS-REx, looking at gas interactions more generally, is how it can be used for utilitarian purposes. So I have poster number 2. I am looking at a couple of notional mission architectures to determine what the instability threshold would be for those and whether or not soil ejecta might be likely on the surface. Once again, my name is Wesley Chambers, and I'd love to talk to you about that if you're interested. Thank you.
Good morning. My name is Arielle Joy, and I'm a graduate student at Brown University with Jim Head. I'm interested in how volatiles are introduced into the solar system, cold trapped on airless bodies, and how we can utilize them as resources on future missions. Today, I have a poster at Lucky Spot number 13, where I'll be presenting new research on water ice exposed at the surface of Mercury at the scales of large permanently shadowed craters down to the scales of micro cold traps. And we're discussing the implications for what this means for the total inventory of water ice on Mercury and also new exploration of the moon. So again, my name is Arielle Joy, and I'd love to discuss my work with you, so please stop by poster 13 today during the poster session. Thank you.
Hi guys, I'm Hannah Kaplan. I'm a 5th-year grad student at Brown University. My work deals with reflectance spectroscopy of organic-bearing rocks. So I've recently measured a number of carbonaceous meteorites and then insoluble organic matter that's been extracted from those meteorites. And we're looking we're looking at them in visible to near infrared wavelength reflectance spectra. And this work has implications for the Dawn mission at Ceres and also for missions to asteroids like OSIRIS-REx. So my poster is number 20. Come talk to me about all of this stuff. Thanks.
So if we could give all of our speakers one more round of applause, please, that would be fantastic. And now we are slightly behind schedule, although we have 5 minutes for the transition instead of 10. So in this room, we will be talking about parallel session number 1, volatiles. And in the other room down the hall is going to be astrophysics and heliophysics. And we'll get started promptly at 10:30, so 5 minutes.
Okay.
Thank you.
So we will see you later. You're going to stay here?
I have to.